Okay, so we've written out the 16 choices,
Mm-hmm.
Okay.
and you've actually paired them together. Like this and like this.
Yeah.
How did you do that pairing?
Well, so these are. So I wrote the 8. Like there's 8, and then if you flip the heads and the tails, you get the other 8.
Okay.
So every case in a row of these 2 columns I've made will have the same average expected value.
Okay, why?
Well, because it's an equal probability. Like it's an equal probability of hitting each letter. You're not like 2/3 for head and 1/3 for tails.
Okay.
So you can replace heads with tails, and nothing's going to change.
Yeah, okay, so it's interesting. So before we start doing the calculations, which one or ones of these do you think is going to take the longest to hit on average?
I'd say probably this.
Okay, why?
Well, because at least from the way we looked at it in the last video, you can have a lot of people going at the same time, so it's going to add up.
Everybody will win.
Okay. Now, before we talked about that, a new way of looking at this problem, why do you think this might be a hard one to end up hitting on?
If you flip, say for this one, if you flip tails at any point, you fail.
Okay.
You go back to the start.
All right.
You've got to flip 4 heads in a row.
Mm-hmm.
Okay.
I mean, no one expects when they flip 4 coins to hit all heads.
Well, it's interesting. So after 4 flips, which of the 16 choices is the most likely for you to have landed on?
Well, they're all the same.
They're all the same.
They're equally likely.
But
After 4 flips,
yeah.
they're all equally likely.
But like the
I mean, you might expect
sets.
to be in like the 1 and 3 cases, or the 2 and 2 cases, and maybe not the 4 and 0 cases, or the maybe you could be in here too.
Well, again, this is the tricky part of thinking about this problem.
Mm-hmm.
After 4 flips, everything's equally likely, but the interesting thing is that doesn't mean the expected amount of time it takes to land on a particular one
Is equal.
is equal.
Mm-hmm.
Okay. So why don't you do the calculation for this one, which will indeed match this one. So we only have to do 8 calculations. Why don't you do, and you can use the Lego.
So it's going to be in the 1, 2, 4, 8, 16 sort of sequence.
Uh-huh.
So we're assuming this person on top always wins, so they always advance. So this person moves. This person moves on. They win. This person comes in also betting heads for the first one. And then it's sort of move like this.
So I guess you would have put them in a line on the third one.
Mm-hmm.
Oh yeah. And then they would all move down and they would all win.
Yeah.
So this person at the top would have won 16. This person would have won 8. This person would have won 4. And this person would have won 2.
Okay.
So it's a total 24 would be 30 times.
Yeah, so on average, this one takes 30 times.
For these 2.
Right, so these 2 together take 30 times. Okay.
Alright.
Why don't you do the next one down, and then after that we'll just do them in our heads and see if we can.
Well, so this one, since no one can win off the end in these cases, like you can't have 2 people win simultaneously.
Why
Well,
not?
I guess except for right at the end. Like you can't have someone start in the middle and win.
Okay.
So this is on the, I'd say it's 18, because it's 16 for your original person and plus 2 if someone comes in right at the end.
Well, what happens to the person who comes in right at the end?
I
What are
guess
they betting?
The
They
person-
don't actually win.
They're betting heads, so they're gonna lose.
Uh-huh.
So this actually is just 16.
Okay, so yeah, so let's think about the second person who comes in here is betting heads, but they're betting this head.
Mm-hmm.
Right, so they win, the second person wins, the third person comes in and wins, and the fourth person comes in here, but everyone except the original person is betting heads at this stage. So everyone loses except the original person. So these actually take on average 16 to win. All right. So what do you tell me? You tell me what you think about this one.
Let's see. So, let's see. This one might also be 16 because when the second person comes in here, they're betting this head, and then on this stage they're betting this head, so they lose. The third person will come in here betting this head. The fourth person comes in here betting this head, so they win. So it'll be an additional $2, so it'll be 18.
That's right. 18. Okay, let's keep going.
This one, the last two people who come in,
Will win.
well, not necessarily actually. So, let's see. So the first person, when they get to here, another person's going to come in, bet heads, and they're going to win. Then when the first person moves to this last one, the second person is going to be betting tails, so they're going to lose.
Right.
But the last person who comes in is going to be betting heads, so they're going to win. So this is 18 as well.
Okay. Let's just check. First person is always wins, so that gives us the 16. The second person comes in and bets heads here, and they lose, so they're gone. So the third person comes in and bets head, tail in the next two segments, so the third person is eliminated. The fourth person bets heads and wins. Okay. What about this one?
So, first person always wins, we get 16. The second person comes in here, betting the heads, so they win. Here on the tails step, they're betting heads, so they lose. Third person comes in here, betting heads on the tails, and also the fourth person also does that. So nobody wins except for the first person.
Okay, good.
This gives us 16.
All right.
This is what we've already looked at, and this is 20.
That's 20. Yeah, so that's fascinating. This one's 20. All right, two more to go. Head, tail, tail, heads.
I guess this one, someone can only come in and win it again on the last one. So, 18.
Yeah, because the second person is coming in betting heads. The third person's coming in betting heads. So they all just lose instantly. And then there. Alright.
And then it doesn't look like anybody else will win on this last stage because these three are all the opposite of the first stage, so everybody else will lose instantly.
Okay.
So 16.
Okay, nice. Cool. Did you find anything in here surprising?
Well, it's surprising that I guess there's so many that don't elongate at all, even though they have repeated like strings of heads and tails.
Yeah.
Like you might think because you're getting you're getting 3 tails in a row, you think that one might take a little longer, but it doesn't. It's actually one of the shortest ones.
Yeah, in fact, it's almost half the expected amount of time is almost half the all heads or all tails, which is really surprising. So, yeah, it's cool. This is a cool problem.
Yeah.
And it shows you that the statistics of finding the expected time to achieve a task is different for even tasks that you might think ahead of time would have all been the same. So, it's cool. It's a cool problem. All right, good work, guys.